Baxter and Friends, Riding Through the Waves. Hi, I'm Baxter, and these are my best friends Millie and Cooper. Guess what we're doing today? Going on a cruise. What did we learn? We learned that refraction is the change in direction of waves passing from one location to another.
Hi, my name is Alex. I'm from Mr. Welty's physics class, and I'll be showing you some of my 3D models I printed. So this first one demonstrates refraction because it's a change of medium from the gummy sticks to the non-gummy sticks. So next is these models of the transverse waves. Next is the diffraction machine. So here, 3D printed these slits, and then I have this. If I bring up my flashlight, so you can see after the wave hits, it'll spread out into a curve.
Hi, I'm Jane, and this is Ride the Wave, my Waves board game, which discusses the topics of waves. In order to play, you're going to have up to 5 people. You can either use a wave, an ocean wave, a transverse wave, a sun, which represents light waves, a longitudinal wave, and a sound wave. My players have chosen their pieces, and now the first player is going to roll the die. Depending on what the die lands on, they're going to move that many spaces.
1.
Since she landed on gray, she's going to pick a gray card. And the person next to her is going to read it to her. When does a wave demonstrate diffraction?
When it passes through a narrow aperture.
That's correct.
As you can see, the top wave has twice the frequency as the bottom wave, meaning that there's twice as many waves per unit of time as the bottom wave. Let's say that the top wave has a wavelength, the bottom wave has a wavelength of 60 blocks, and the top one has a wavelength of 30 blocks. Here is our example of diffraction. As you can see, the slit width on the left is 5 units, and the wavelength is also 5 units. So we're going to have maximum diffraction here, meaning that the waves are going to spread out across the entire 90-degree arc from this all the way over to the stone wall. And then here, the slit width is 9 and the wavelength is 5, so the diffraction is going to be a lot less.
Life is like a wave when you really think about it. It's defined by disturbances as we move from one to the next. Energy is always transferring with your mood, and the energy is transferred from the day you are born to the day you die. Some days, the frequency of the wave is high, and you can have a bunch of highs and a bunch of lows in one day. In that case, your moods last a short period of time, and they continually change throughout the day. Some days, the frequency of the wave is low, as you are either mostly happy or sad, and there are less mood changes. Maybe very few things happen throughout the day to provoke any emotion. Waves in our emotion have different kinds of causes or disturbances. Oftentimes, the disturbances occur parallel with our moods, similar to longitudinal waves. In other words, we know exactly why we're happy or exactly why we're sad. If it happens to be a day with a bunch of highs and lows, it's a compression kind of day. If it happens to be a day with a more constant feeling, it's a rarefaction kind of day.